Hey everybody, my curriculum is on simple machines. My third activity is on inclined planes. Um, each of the activities starts out with a hands-on activity and then goes into a technology web-based site where it's an interactive activity. This one is on inclined planes. The kids start with, they're in a small collaborative groups. They get an assortment of carts and they have to um, basically pull them up various angled inclined planes, and they're going to basically register the amount of force using a spring scale. Um, when they complete that, they're going to go to a website called aspire.cosmic/ray.org, and there they have a lab packet that I have for them, and they start with pulleys and inclined planes. That's the first activity. Then the second lesson, and the second lesson is just pulleys, and then the third activity in the lesson, this one, is inclined planes, and they can manipulate the ramp, they can manipulate the amount of workload, and every time they adjust something, a fulcrum, whatever it is they're working on, it'll give them a numerical value, and they are able to calculate the work, which is force times distance, and they can also figure out the mechanical advantage utilizing the ratios of output input. The lab packet goes, it's pretty extensive and it's pretty deep. It's all Common Core aligned, and them and their partners, work on that. When that is done, they also create their own spring scale, which is pretty cool. Once that's done, they are basically going to draw a conclusion, and they're going to justify this conclusion by using their tables, graphs, and observations from the collected information. The things that basically their context or goals, the students will calculate the amount of work done when the force is applied to an object. Students will use inclined planes to recognize that the amount of work output is never greater than the amount of work input with or without simple machines. Students will recognize that the inclined plane is a type of simple machine. Students will use their observations to justify a conclusion. Standards, we have science standards, invest and describe how machines can use motion to do work. We have ratio and rate reasoning, use variables to represent numbers and write expressions, which is math. Follow precisely multi-step procedure when carrying out experiments. It's technology. Compare and contrast information gained from experiments and simulations of video or multimedia sources. Draw evidence from informational text. So I have writing, reading, math, science, technology. The big idea is that the angle of an inclined plane is proportional to the amount of effort needed to move an object a certain distance. The essential question for this activity is, if you had to build your own pyramid, how would you carry heavy stones up to the top? The assessments are going to be the formative assessments. Are going to be two relative questions after the activity lab, questions answered in the lab packet on the inclined plane online activity, the tables that they generate to show the work, force, and distance, and then they're going to answering the essential question through an expository essay by utilizing and explaining observations in the activity. The summative assessment for the curriculum is each student is going to build their own Rube Goldberg machine, which is basically a machine that uses a lot of compound and complex systems to do something very simple. And they need to use 4 of the 6 simple machines. They need to basically utilize their prior knowledge on potential kinetic energy, transformation of energy, and create this system. They're going to do this at home. They're going to videotape it, and then we're going to put it on the classroom website. That's all I can think of. If you have any questions, please get a hold of me. Thanks.